Okay, in this video, we're going to be looking at conjugates, what they are, and how we're going to be using them in calculus. Okay, so if you have a binomial expression like x minus 3, then its conjugate is just going to be basically the same binomial, but with the opposite operation in the middle. In other words, if it's a minus 3, then its conjugate would be x plus 3. If you've got 3x plus y, then its conjugate is 3x minus y. If you've got a plus 7b, its conjugate is a minus 7b. So it's the same two terms, just with the opposite sign in the middle. Conjugates are useful because, as we saw when we were reviewing factoring, if you multiply two of these together, the middle term is going to cancel out. You'll have x times x is x squared. X times 3 would be plus 3x, and then you'd have minus 3x. Those middle 3x's are both going to cancel one another out, and then you'll have minus 9. So conjugates are useful in algebra and in calculus whenever you need that middle term to kind of disappear. And you're going to see why that's useful here on the next slide. You're going to see how all this connects to calculus very soon in class, because we'll soon be looking at how to deal with limits with algebra, which is why we're reviewing algebra, in addition to looking at limits with the graph and with the table of values. Okay, so let's say in this situation that we need to get rid of the 16 minus x in the denominator. Just go with it for now. The way that we can do this is by multiplying by the conjugate of the numerator to get rid of that square root of x. So here's going to be our trick. Wherever you have the square root, we're going to multiply this fraction on the top and bottom by the conjugate of that, wherever it has the radical. If we've got our square root of x on top, that's a radical. So instead of multiplying by square root of x minus 4, we're going to multiply by root x plus 4. And, you know, by the basic 101 rules of algebra, whatever we multiply by on the top, we also have to multiply on the bottom, just to make sure that we're multiplying by something that's equal to 1. That's why that's kosher. Okay, on the top, that conjugate special magic is going to happen because square root of x times square root of x becomes just x. Root x times positive 4 would cancel with the negative 4 times root x. So in other words, those, the outside and the inside, if you will, are going to cancel. And then you'll just have negative 4 times positive 4 becomes a minus 16. Okay, so again, what's happening is you've got root x times root x plus 4 root x, that's plus, minus 4 root x minus 4 times 4 is 16, and those two middle terms cancel out and you're left with just x minus 16 on the top, which is going to work out really conveniently here in a moment. On the bottom, because you're multiplying two completely different things, you don't actually want to like FOIL those together. What we're going to do is just put each binomial in parentheses and kind of leave them each be. So we're going to just have 16 minus x and root x plus 4. Now, we said here in the beginning that our goal is to kind of get rid of that 16 minus x, and now look at what we have on the top. We have x minus 16, which is very, very close to 16 minus x. And we're going to do a little bit more creative algebra here, if you will. Let's look at that numerator. If we wanted that to change into a 16 minus x, in other words, we want to kind of change the order, let's factor out a negative 1. You can always factor out 1 and it wouldn't change, but if you factor out a negative 1 in other words, if you take the x and you take the negative 16 and you divide both of them by negative 1, x divided by negative 1 is going to be negative x. Negative 16 divided by negative 1 becomes positive 16. We're only doing that on the top because we're factoring it out, so we don't have to do anything to the bottom in this step. So the bottom stays, the two binomials just kind of chill. And look at what this does. This is what I like to call creative algebra. we've got that -1 on top, and if we change the order, which, you know, we can by the commutative property, then we have 16 minus x on top. Aha! And we also have 16 minus x on the bottom. Aha! Now they will cancel, like so. And now we are left with a much cleaner expression than we started with. And when we start looking at limits analytically, you're going to see why this is useful in calculus, this kind of neat little trick. But that's how we're going to be using conjugates in calculus. So to recap, here's what we did. We took whichever term here circled in yellow, the root x minus 4, we took basically whichever part of the fraction had a radical, and we multiplied top and bottom by the conjugate of that radical expression. So because it was root x minus 4, we multiplied top and bottom by root x plus 4. And that caused the root x to disappear on top in such a way that we were able then to take that x minus 16 that resulted from that conjugate and manipulate it by factoring out a sign such that we could cancel something else. So that's what we're going to be doing with conjugates in calculus.